I am just now realizing that I have forgotten an affiliation. So December and January, I'm also currently faculty at the University of Michigan in their data science master's program. So second affiliation. I know some of y'all are in Michigan, so I'm not, but we share something there. So this is a very opinionated talk. I'm going to share a little bit more about my background in a second. But the top line takeaway is that I don't know, was it the Mark Twain's reaction to his death notice, like reports of my death have been overstated. I know there's a lot of folks here in industry, so I think this is probably not going to be a surprise for a lot of you, but you need rules to build certainly conversational systems. They are not removable quite yet. And I'm going to talk a little bit about Rasa architecture and where we use rules and sort of our ensembling, both for NLU and dialogue management. I don't have the chat pulled up. All right, so first of all, a little bit about me. I am unused to only presenting on one screen, and I am feeling a little bit squozed. So my undergrad is actually in linguistics and English literature. So from the University of William and Mary. I know some folks from DC, you might have heard of it. It's a little school on the East Coast. And I got into language technology because I got into linguistics actually because I was really interested in language technology and helping build language technology that it worked. And in, the halcyon days of undergrad, I was like, well, clearly primary linguistics research is going to be the most impactful thing for building good language technology. And I was wrong. I was very wrong about that, I think. So I did my PhD, as Seth mentioned, at the University of Washington. And my focus was really on describing variation and how well systems handled it, and then proposing solutions, basically. So the main focus of my my dissertation was on phonetics and automatic speech recognition, more on the speech side. But I also did quite a bit of work on text, especially in the subfield of computational sociolinguistics. So, if you're familiar with, I'm trying to remember the precise name of the workshop. Dialects and related language varieties, I think is the name of the ACL workshop. Very relevant to that. And also ethics, and then FAT is fairness, accountability, and transparency. And that acronym has now mostly been changed to FACCT in NLP. So those were my sort of main areas in graduate school. And then after grad school, I went to Google, where I started as a data scientist and then transitioned into my current role, which is developer advocacy, which is more of an educational role externally. And then internally, I am, a user of the product with lots of opinions. and that's my role. And at Kaggle, I was working on, general machine learning topics. I imagine most of you are familiar with Kaggle. It is not NLP focused. And then I moved to Rasa, where I am currently. And I primarily support our open source conversational AI framework, Chatbot framework, that has, we'll get super into the weeds on that. But we also have a closed source but free to use project called Rasa X that allows you to do data annotation and do CI/CD and model training in a nice interface. And if you're an enterprise and you want the enterprise version, you pay for it, and that's how we make money, which I think is, good to know about companies. So with all that in mind, that's me. I come from a very heavy linguistics background. I care a lot about language and really making language technology the best that it can be is sort of my goal in life through, in this case, developer education. And with that in mind, again, I imagine this will be peer review for many of you, but it might be sort of news for some folks who may be earlier to the field or came into NLP through machine learning background. But the sort of progression of NLP has been from the very early symbolic rule-based systems towards our current state of the art, which generally includes some flavor of transformer. Oh, it's like I see the chat. Yes, which includes some flavor of transformer usually. And dialogue systems have been here throughout. So I'm sure many of you are familiar with LISA, the very I would say probably the very first dialogue system that people were excited about, which is completely rule-based. So the way it worked is you produced an utterance that was parsed, rephrased as a question, and produced back to you by the assistant. And that went back and forth. So it was supposed to mimic psychoanalysis. A particular school of psychoanalysis, I can never remember the one. I want to say Jungian, maybe, not my field. And then during, I guess, as a result of the first major AI winter, there was a big shift in the field towards statistical methods and counting stuff and not building rules quite as much. And this was what was, when I was starting to get into linguistics, this was currently the state of the art. And we were sort of coming from the end of the statistical math era towards the beginning of the neural era when I started in the field. And this was things like, Markov models, transitional probabilities, a lot of statistical modeling. And then, of course, the change to neural methods, especially when I was in graduate school, the hot architecture was bidirectional STM with attention. I would say no longer the most exciting architecture that everyone is very excited about. Because in 2017, the Vaswani paper, transformers started to really pick up steam, and that's sort of the current state. And none of these have gone away. And I'm sure those of you who have been in the field for quite a while have used all of these and probably continue to use all of these in products that you're building. And in particular, rule-based systems. Rules can be very powerful and they can be very fast and they don't require data. And for many applications, that is deeply important. I'll talk about that in more depth, but this is sort of the historical context. Again, maybe review for many of you, but maybe for some people it's not. I think it's helpful to know about the history of fields. So neural methods, I think we're all familiar, universal function approximators under certain conditions, really good at handling unseen data that is representative of the population it's been trained on, or the sample it's been trained on, probabilistic, all those good things about neural methods. But the downside of neural methods, when you compare them to things like rules or even statistical methods where you have statistical guarantees about behavior, are that they are unpredictable. So my strong recommendation to everyone in all situations is not to serve raw neural generated text to users. I think we're all familiar with Tay, the Microsoft chatbot that went off the rails because it was folding in, user-generated data that was from a population that was intentionally trying to poison that data, and very quickly started to say, horrible racist things. And then this is from early this year. There was a South Korean chatbot that ran into much the same problem, and it was just trained on raw user data, and then was using language generation, neural language generation, and was serving, homophobic text to users, which was certainly not the intent of the developers, and was, a bad experience all around for everybody. I don't think anyone wanted that to be the intended outcome, but I would just, give you some warning stories, and I would strongly recommend against doing it. And they also require a lot of training. So compute time, which is not free, I'm sure y'all know, and also data to tune or train, which is, again, not free, and in many cases, just straight up not available. I noticed when everyone was introducing themselves, based on your locations, I imagine many of you are working in languages other than English. So it is not a surprise to you that data paucity is an enormous issue. Yeah, Don was like, same thing happened today. Yep. I am obviously not happy that this happened, but I guess it is illustrative to have a more recent example. Yeah, and Jim talking about my discussion with GPT-3 on Clubhouse has led me to believe its strongest motivation is to try and figure out how to get people to stop trolling and try to manipulate it. I think it's maybe, you may be talking about the developers there. I may be misinterpreting this, that you are assigning agency to the model, which I would not do personally. Yeah. Yeah. So neural methods, we all know that they're great at what they're great at. They've opened up huge areas of NLP that were really not, commercially feasible before and are now, but they have their drawbacks. Another point on requiring a lot of training data. So this is a paper from, I guess 2 years ago now, 2020, on yeah, I anthropomorphize just like people did to Eliza in the 60s. Yeah, it's so tempting because if it talks back to me, it must be a thing that can talk, and things that can talk are language users, and language users are people, right? There was, I think it came out yesterday, actually, a little bit of a sidetrack, but Blaze last name from, sorry, I've forgotten his last name, from Google published a piece being like, when should we give AIs personhood? And I have very strong thoughts on that, and we can talk about that later. But yes, I think anthropomorphization is a very easy trap to fall into, and also a trap, both of those things. So great example here from Vietnamese. I don't know if anyone here is working in Vietnamese. It is one of the more common languages for people to build Rasa chatbots in that we have information on. And these are a comparison of some of the embeddings that they were using in training their chatbot. Yeah, I see the motivation trying to encode rules and prompts. So this was embeddings that they were, yes, definitely, that can help a lot. Sorry, I should not have two conversations at the same time. I'm gonna finish talking about this figure. Top line is the, I believe it's fast text. Yeah, so top line is fast text. It was hidden behind the chat windows. The middle line is TensorFlow, just like raw TensorFlow embedding Sparse. And then the bottom line is MBERT, multilingual BERT, which in theory includes Vietnamese. Those of you who've worked with MBERT, I've heard really differing reports about how well it works on different non-English languages. And as you can see, if they had continued to have training examples for tuning MBERT on their training data, they might have eventually got to the point where it did better than the TensorFlow or the fast text models. It's definitely like, you can see the trend. But this is 700 training examples per intent, which is, I would say, in almost all applications, especially for prototyping, too many. And even 300 is quite a lot. So in situations where you don't have an enormous training data set before you begin, which is, most situations with non-English languages, you're going to run into this problem where you just don't have enough data to tune these really large models to be helpful. And I think this slide is probably a review for all of you. And I only did this through sort of halfway through 2020. I haven't gone back and redone this figure for a while. This is just sort of number of parameters and models over there on July 2018 and around, was that probably August 2018. There's two little lines on the zero axis. Those are models. And it's been exponential increase in number of parameters. I think this is not, again, a surprise for anybody, but in order not to have an over parameterization, you need to have a training data set that, doesn't leave your model underbaked. And that's only really an English thing currently. And I really only see that in the future, unfortunately. So just, again, just a review for y'all, I'm sure. More worryingly, the types and severity of adversarial attacks on large language models, I think we're only really beginning to scratch the surface on. And I genuinely think we do not know about the biggest security risks they pose. But a big one, and this is GPT-2, not 3, is that you can extract underlying training data. And I think we all know this about models, right? That it is possible to reconstruct the underlying training data, but in this case, it includes PII. And I have no reason to believe that they've removed all the PII successfully from GPT-3. So, a pretty major security issue. Another great reason not to serve raw text to users, not to serve raw generated text to users. So with that in mind, again, neural methods, they're really good at what they're good at. We need flexible systems in some applications that can genuinely open up new avenues of inquiry and work. But also, rules are good sometimes too. So some of the really big benefits of rules is that they're reliable. You know exactly what's going to happen when a rule is triggered, and you know what conditions are going to trigger the rule. And those of you who interface with, product owners and people on the business side a lot know that that is often something that they are very concerned about, particularly in highly regulated situations. They're also easy to interpret. It's very easy to say, why am I doing this? Well, X, Y, and Z. You can clearly see if I do this, this will always happen. They also don't require training data, which I know that we live in an age where it seems like training data is this, vast and exhaustible lake we can keep drawing buckets of water from. But again, if you have that stance, it's probably because you work in English. And I know I keep beating this drum, but the majority of people in the world don't speak English. And if your system only works in the specific situation that English is in right now, it is not a general purpose language system. It is an English knower system. And that might be fine for you and your applications, but it's not going to be fine for everybody. And it won't be fine for the majority of people. Jim says, NVIDIA has been claiming superhuman performance in tech support and customer service chatbot tasks for at least 2 months now. That doesn't say minutes. Not surprising, given that nearly all games of skill have been programmed at superhuman levels. Yeah, I haven't read this paper, so I don't know that this is a paper. I haven't read the underlying thing that you're talking about here. It is very difficult to show superhuman skill. So this is my opinions again. It's very difficult to show superhuman skill in the realm of conversations. Most conversations are hard to measure, right? So this is a little tangent, but I think it's worth talking about. So imagine you talk with a friend, just like on the phone. And of course, that's chit chat. That's not a task-oriented dialogue. But imagine you're talking with a friend, and let's say even you're trying to figure out where to go to dinner. And at the end of the dialogue you had with another human, if I asked you both to rate how good the dialogue was, there's no guarantee of agreement. Or even if I asked, 5 people who are not involved in a dialogue to rate how good the dialogue went, like how good was this conversation, right? Their cultural background is going to affect that. Their, expectations, behavior are going to affect that. Their relationship with the people who are talking, if they have one, is going to affect that. Their knowledge of background information that may not be shared in the conversation is going to affect that. So it is really hard to measure the performance of conversation, which is a problem in the field that I don't think has been solved. And there's a link to the thing. I don't want to open it now because it'll kill my slides, but I can open up at the end. Yeah. So that said, I think where you can get superhuman performance is how fast can someone get access to the certain resources they need? How fast can they go through a process? And if you can do that faster with a chatbot than you can with a human, then I would say, fantastic, it works great. I think that's an ideal interface, right? Same like, I'm only going to call a person if I can't do, and this is my personal bias, I'm only going to call a person if I can't do what I want to do online first, because then I have to call, I have to wait for them to pick up, I have to describe the whole situation that I'm in, I maybe have to go through a phone tree, and all of those things take time. And if I can do it faster, a different way, I would love to. So I think that you can have, faster than human support. I think that's a great metric to look at. Better than humans at having conversations, I think is hard to quantify. Rule for intent classification or during text generation as well. Great question. So yes for intents, yes for dialogue, and then yes for text generation. So I'm a big fan of template-based models where you write, or a conversation designer writes the conversational turn, and then you fill in the slots with the relevant information for users. And again, if you've been in business situations, you've probably had discussions about where, if you've worked on chatbots in a commercial setting, making sure that the chatbot only says exactly what you want the chatbot to say is a pretty consistent concern that people tend to have. It's an hour talk. Yeah, I'm perfectly happy to keep interacting with the chat. And I guess stop chatting if you want to keep going. I think we'll get through it, and I imagine there'll be also quite a few discussions once we get to the architecture slides. Anyway, rules are predictable. That's great. That's the thing that people want, and they don't require training data. Also very good. The downside, again, anyone who's been in NLP for a while will be very familiar with, is they're very narrowly defined. Systems of rules in particular are rough or very, very rough. So if you've ever worked with one of the older sort of dialogue tree based systems where everything is, done by rules, so what happens next in the conversation, everything is written by rule, and you have a tree that you step through. Editing those and perhaps helping people move around the tree is very difficult. It is a very rough thing to do. Also, they don't adapt to unseen situations, right? Your rule is going to cover what your rule is going to cover. It's not going to make a best guess in the thing that it doesn't cover. And that's a big benefit of neural models, is that they will make a guess. And of course, they're not getting as much press coverage. No one's writing articles about how cool rules are. No one's written the blog post, the unreasonable effectiveness of rules. Probably someone has, actually, now that I think about it. But it didn't get a bunch of, chit chat on Twitter. Nahed, sorry if I'm saying that wrong, says, I'm working on both Arabic and English. What about using a model like GPT-3 and using it to translate from, for example, from Arabic to English, and they're solving the problem that you have in mind? What do you think about that? Great question. I think it really depends on if, when you say you're working on English and Arabic, you're talking about code switch text, or you're talking about two separate models. So code switch text would be if someone was using both Arabic and English together, or two different languages, two or more different languages together in the same utterance. So like English would be an example of, well, it's more like a contact variety, but it's also a good example of code switching if someone's going back and forth between English and Hindi. If that's a situation that you're in, I would train a custom model for that. I personally have not yet been in a situation where a large language model is the best choice for me. I just haven't been there. Translation, so adding a translation to and from step as part of your chatbot, I would recommend against. I would probably actually just train an English model, train an Arabic model, and then have people pick which one they're doing and do sort of like a parallel architecture there. And then once you have it to your structured text after your NLU, you can then use the same dialogue system or dialogue policy as well. Don says, sense disambiguation is that specific task that you're looking for. So case being like a case you put your glasses in, or case being like a legal case. Is actually training? Yes. So if you're using a bag of words model that does not include context, you will have to worry about sense disambiguation. If you're using a contextual embedding, you will not. It's sort of my very top level thing there. But I would look into word sense disambiguation as that specific task. Yeah. Thanks, Jim. All right. So we'll talk about the NVIDIA thing later. Yeah. Also, I did say at the beginning of the talk that I was down to be interrupted, so I don't mind it. All right, rules. They're good for some things. Neural networks, they're good for some things. So let's talk about how we use them at Rasa. So this is a very top level diagram of how most dialogue systems work. So you have the user input. It goes through NLU, the process of taking that raw text and converting it to some sort of feature set you can use. Dialogue management, picking the next thing for your assistant to say. Response generator, again, I would recommend using templates and slot filling there. So instead of like generating something about where the person's going, having a template that's like, you've booked a flight from entity to entity on time entity. Is this correct? Instead of having that completely be neurally generated, I just strongly would recommend against that with our current state of things. And it's a little bit, this is sort of a good conceptual distinction between the NLU and the dialogue management. Certainly in Rasa, that is no longer functionally there. So starting in Rasa 3.0, this may be news to some of you who haven't used Rasa in a while, the relationship between steps in the NLP pipeline all the way through picking the next action are now controlled using a DAG that you can customize. So instead of being a pipeline where you step through that's chunked into different components, it is components that you can arrange as you like with the dependencies that you like, and it's much more customizable. And also we've had end-to-end for a while now, so instead of having Yeah. So the big thing about end-to-end is that we're not actually doing intent classification. So no classification, just taking the raw input, converting it to features, putting those features raw into the dialogue management, and then having the correct output be selected, hopefully, fingers crossed. So this is at a very high level, generally how most dialogue systems, including Rasa, work. Yeah. Oh, I have to mark the question as done. I was like, why is the question still there? Yeah. And Peter, if you have a question, feel free to chat. Is there a golden rule which we should use in which case? That is a great question. It depends on the specific domain. So we're actually about to talk about it. I'll just advance the slide and I think it will be be answered. So this is our neural approach to the NLU part. Again, you may or not be using a complete separation between the NLU and the dialogue policy. So this was developed at Rasa. It's called the diet classifier, dual intent entity transformer. I always get the words backwards, classifier. And I will say that we don't actually use pre-trained embeddings in the default config for Rasa, and I'll talk about that in just a second. So you have the sparse features from your text input, using whatever featurizer that it is that you choose, and then it's a dual task. So intents are turn level labels. What is it that the user wants to do based on intents that you have provided and given training data for, and those will depend on your specific domain and use case. And then entities, and this is a character level extraction from the text of extraction and then labeling. So in this case, the address 222 Broadway, New York City is being detected as an intent, is being detected as an entity, extracted and labeled. So this is the transformer-based way of doing it. Oh, I think I've accidentally deleted a slide. Oh wait, is it after this? Nope, it ain't. But we also have a lot of rule-based ways of doing this. So you may have noticed for addresses where you're going to have, some number of digits, 0 through 10, and then, some, street name, and then perhaps a, small number of things to describe streets like avenues, boulevard, street, etc., and then a city, and you sort of know what the city's going to look like, and then say a state, and then say a country. You might be saying, Rachel, that's highly templatic. That's something we could identify with a rule. Yes, I would strongly recommend you use rules there. So in particular, we use Duckling. If you're not familiar, it's a regex based tool. So built by hand to extract time, addresses, email addresses. I mentioned times already, but basically those sort of like very templatic entities that you might want to extract and then label and then save. I would never build a neural network to identify email addresses. That way lies madness. Email addresses are extremely predictable in their structure. You can write a regex in 5 minutes. You would need to provide so much training data to extract just and only email addresses. And even then, I don't think you'd get a good guarantee of that. So that's a great example of a place where a neural network would not make sense and a rule would. But address is a very common type of entity. So we're using here just for exemplary purposes. Yes, Duckling, which I believe, is currently owned by Facebook. And I believe they also ported it from Haskell. I think it was originally written in Haskell and no longer is. And they don't only support English as well, I should say. They have modules, I believe, for a wide variety of other languages as well. So great tool. I love regexes, especially ones I don't have to write and I can use that other people have written. And you get, big time savings, big money savings, and very predictable output. What kind of sparse features are you extracting from Diet Classifier? Great question, Rachael. Let's go to the more complex architecture diagram. So a couple things here. This is for training, so we are including the mask. In prediction, there is no mask, and also this bit at the side to identify the mask is also removed. And also, we don't ship it with pre-trained embeddings, like I mentioned. So when in the paper, we use convert embeddings, which is a conversational embedding. They changed their license earlier this year, 2020. I don't remember when they changed their license to really restrict use, so we no longer use them. And also, we get really good results without them. So the sparse features are just from, I believe the default is just like, I'm trying to remember, it's changed recently. It's just like a covariance matrix that we collapse through the feed-forward layers. So it becomes denser features, but it's very, very straightforward and comes directly from the training data, which means, because there's no pre-trained data and the sparse features come directly from the training data and the tokenizer that you choose, it is, in theory, language agnostic. So you should be able to use it for other languages. Someone was just mentioning recently that they had been using it with German with really great success out of the box, which is fabulous. And I'm very happy to see. So yes, and these can be any sparse features. So I mentioned that we have a DAG backend. You can plug in any features that you like. You can add any pre-trained embeddings that you like. It's a very flexible architecture. One of the benefits of open source. So that's the transformer bit. And then the conditional random fields is just second piece of input into specifically entity extraction. That's a fairly standard method. And it is dual entity. It is multitask, getting both the intents and the entities. So you take a combined loss over it. And this is just sort of the general idea. Again, if you are using a lot of, if many, if not all of your entities can be extracted using regex, then just don't annotate any intents and it will just be an intent classifier. Don't annotate any entities and it'll be an intent classifier. Anonymous says, so we extract hi at example.com and supplement it with something like email intent to email address. Are there similar kind of output rules? Great question. So if there's a lot of ways that you can handle this in Rasa. So the underlying text string is maintained. We're not removing that. It is being featureized, so we're turning it into numbers basically. And the hi at example.com would be extracted. So added, it's an item in the JSON payload. And then if you've specified a behavior about wanting to save specific entities from the text to a variable, we call them slots. Confusingly, slightly different from the way that other people talk about slots. But if you want to save any variables over the course of the conversation, you can save that to a slot. Otherwise, it's just attached to that turn in the dialogue. And we also maintain the raw text of the dialogue unless you do that somewhere. Sarthak says the input to diet is sentence and intent. So it is just the input is just what the user has said. Say I'm going to answer that one live. The input is just what the user has said. The intent label is generated by diet, and the entities extracted are extracted by diet. If there are entities present, you will always get an intent classification. You will not always get an entity extraction, if that makes sense. How do you calculate loss? You identify all the entities and don't identify the intent correctly versus you identify the intent and only one of the entities. I don't remember off the top of my head. I believe it is weighted in some way. I'd have to go back and reread the paper, sorry. I hope that answers your question. Yes. All right. And hopefully that also answers your question, Anonymous. Ming says, how do you avoid entity, intention, and intention tasks to correlate? Great question. You want the correlation, right? So the fact that you will provide specific type of entities in specific turns is important information that helps your system performance overall. So imagine you know, I have a chatbot. This is my face as I try to come up with an example. I have a chatbot for ordering food at a restaurant, right? So in turns where I'm like, hey, what are your hours? And then they say their hours. And I'm like, or something like, hey, are you open on Sundays? So there is an entity in there. There's a time entity that I might want to extract. In turns where I am asking about when they are opening, I am probably not asking them to list out their ingredients in a recipe, right? So I might say like, hey, do you have any dairy allergens in your pizza marinara or whatever it is that I'm asking about? So the fact that there is a relationship between your entities and your intents is part of the reason why it makes sense to treat this as a multitask architecture, because they share information. So the correlation is there and it's not an issue. Hopefully that makes sense. Yeah. Entity messaging is waiting. I'm pretty sure it is. Do we do part of speech filtering? No, I don't believe so. I actually don't think we do part of speech tagging, period, certainly in diet. You could add it. You could add it if you needed to, but I don't believe that we do. Varesh says, I'm new to conversational AI. Welcome to the field. And in a recent proof of concept for an FAQ bot, we intended to use a neural network dialogue manager as much as possible by providing multiple stories with different paths based on slot values. But the POC due date rules were the only option to make the response. The bot respond with sane utterances. Oh no, it seemed to work okay, but we knew how we were forcing the responses via rules. If there are many slots and the conversation has multiple branches, forms, what's the best way to train the bot and make it respond based on context? It's a great question. So this sounds like a fairly Rasa specific question. We haven't talked about the dialogue management yet, so I'm actually going to table this until we talk about the dialogue management, just so everyone else isn't lost. But it's a great question, Varesh. All right, so this is sort of the general idea of how diet works. And like I said, this is used for some things. If you have entities that can be extracted via rules, the rules will always trigger first, and you should do that because it will make your life easier. All right, now let's talk about the dialogue. So we do use a machine learning based policy that I'll talk about in just a second. But we also use rule-based policies. Actually, I think I switched the order of these slides. So I guess we'll talk about the machine learning policies first. So our Keras policy, this is the face of me trying to remember what the state of this policy is in 3.0. I think it might still be in 3.0, but we potentially may not support it always into the future. TBD. But basically it's an LSTM that predicts the next action based on the history of the action. So each turn you have your intent, you have may or may not have slots. So these variables that you store over the course of a conversation as a feature, you may or may not have entities. You can choose whether those affect the course of your conversation or not. And it predicts the next turn. And the next turn could be something the assistant says. It could be, code that the assistant executes. It could be, asking for additional information. I guess that's something else the assistant says. So it's what the assistant does next is not just what it says next. And then we have the TED policy. I'm trying to remember what the acronym stands for. Transformers, dialogue. The T is dialogue. And this is a transformer-based policy. So TED is really designed to handle digressions. So this is when someone's talking about something, I'm ordering a pizza. Oh, hey, is the weather going to be nice while I'm there? Assuming your bot can handle that. Maybe your bot's like, hey, I can't answer questions about the weather. Do you want to keep ordering your pizza? Oh yeah, sorry. And I want like olives or whatever. Transformers are especially good for that type of task because they don't have the same sort of recency weighting that a lot of gated LSTMs do. So you can have, attention over your dialogue. Hey, this is the relevant turn. Given this turn, this is the one that we should use to pick up the conversation and continue doing what we're doing. For both of these policies, the training data for it is going to be what we call stories. So these are templates of conversations. And it can be things the assistant says, intents from the users. It can be things the assistant says, raw text of the user inputs if you're using end-to-end learning. It can be, hey, the assistant has to ask for these 5 pieces of information right now. If 3 of them have already been provided, just ignore those bit and ask for the 2 that we don't have quite yet. So generally some of the machine learning policies, and I have the TED architecture on the next slide as well. Yeah. Jim says the transformers derive functions of part of speech tagging, but not things like quotation, hyperbole, sarcasm, irony, and ambivalence. Yeah, hard to model. Or digression. Yes. Yes, the reason that it can handle things like digression is because, if I have been talking about something and then I change and then I want to change back, I can skip the irrelevant dialogue turns when deciding what to do next, right? They'll just get lower attention, hopefully. So bots are ADHD free. That's great news. I don't think that chatbots can have disorders. All right, so those are the machine learning based policies. And Manoush wants to know, can you please explain how to create rules for intent detection based on intent definitions or a few examples per intent? Rules seem to be more useful for entity extraction. Yes, they are. Intents are the type of thing where it makes a lot of sense to use machine learning because you can say the same thing or present the same sort of underlying information in an enormous number of ways. So a great example would be like in Japanese. I don't know what the honorifics would be with a chatbot, but someone might just pick different honorifics that you trained with, in which case you'd have, a huge plethora of different ways of expressing stuff. Japanese is a very rich honorific system, or a lot of languages of Australia also have very rich honorific systems. And depending on the honorific that somebody picks to talk to your chatbot, you may have completely unseen training data. So intent detection in particular, I think is a great place for a neural architecture, and I think it's one of the things that have made chatbots hopefully less frustrating to use and will continue to make them less frustrating in the future. Yeah, great question. Don says they're laser focused on learning. Sure are. And I will talk about rules in just a second, because from this, these two policies, you might be like, well, aren't you just doing, guessing using neural networks at every turn? Not the case, actually. Little spoiler alert. I would say for the bots that I've worked on, the sort of I would say less than 10% of turns are handled by TED. Most turns are handled by other policies that are rule-based. So this is the architecture for TED. So on a dialogue turn, you are using a bunch of input information, the things the system's done, the things the user has said. Slots are those variables that you're storing over the course of the conversation. So things like if somebody gives you their address, you might want to save that until they place their order, or items in their order, or even the username or account. If you're doing like verification stuff, you might want to put all of that in slots. The user intent entities, so what the user said on this turn, all of those are put into a unidirectional transformer because you don't know the future. So if we're bidirectional, you would be peeking at the future, and that's no help outside of the training scenario. And then looking at all of the system actions, you compute similarity between the embedding layer for the prediction of the next action, and then all of the possible actions, and you pick the one that looks the best given those. Like I mentioned, this only gets fired maximum 10% of the time. And I would say 10 is actually probably pretty high. And that makes sense, right? This is really good at handling digressions. This is really good at handling surprising turns that rules would break. And those are the times when someone is very frustrated with a chatbot. So I still think it's worth the investment to handle those edge cases in a less surprising way. But it handles the minority of inputs for sure. Jim says a typical failure mode is just repeating the same word or phrase dozens of times or more, which kind of seems like stuttering. It is dehumanizing, again, my opinion. I find it pretty dehumanizing to humans to compare, automated system output to different types of human behavior, particularly if it's something that's stigmatized. So I would just steer clear of it personally, my recommendation. Stephen, great question. Yes, I was not super specific about what task you were talking about. When we say dialogue or conversation, aren't we really just talking about the subset of narrow domain-specific interactions oriented towards a small set of tasks intended to move/prod the user towards a small set of actions? Buy a plane ticket, order pizza, schedule a meeting. Not handle general stuff like tell us why you're unhappy with our customer service and how we could improve it, or even broader stuff, what do you want to do in the next year? Great question. I would actually say that those last two still fall under the general heading of task-oriented dialogue systems. So for the last one, for example, it might be for a planner app to help you, apportion your time and handle your capacity. Particularly for like collecting information about why someone's unhappy, that could be just, opening a ticket and putting the text in the ticket. The chatbot does not necessarily have to respond to the content of that text. But yes, this is, I should have clarified that from the beginning. Rasa is for task-oriented dialogue systems. So these are systems that are user interfaces that people come to and they want to do something with. You could build a chit chat. So chit chat is the general task of having open-ended conversation. You could build a chit chat assistant with Rasa. It would be very difficult. I wouldn't recommend it. And also, I would really dig down into why open-ended conversation is important to your system. In the vast majority of cases, when I've been talking to developers who are working on projects or product owners, when they've talked about, wanting to have open-ended dialogue, it's been because, they thought it would be cool, and perhaps it would be, but it will, require orders of magnitude more work and time. And in general, I don't think that trade-off is worth it. Yeah, it is. Yes, this is not for all types of conversations you might want to have. It is specifically for conversations where you want to do something. Thank you so much, Kat. Transformer Embedding Dialogue Policy. That's what the E stands for. I appreciate that. Steven says, I'd call it a script rather than a conversation. Ooh, that's a great point. So I think that brings me to the next slide. This one, yeah. Rule-based policies. So these policies that we talked about previously, the Keras policy and the TED policy, are machine learning policies. I mentioned that they handle the vast minority of conversations. The majority of conversations are, again, based on my experience on the chatbots that I've worked on and help people develop, come from the stories themselves. So I didn't tell you what our role-based policies are. I was keeping that as a little secret. So probably the most powerful policy in Rasa in terms of like how often it procs is the memoization policy. That's not memorization. There's no R in there. Memoization policy. And this is where the stories that you've provided, the training data, yeah, sure. This is where the stories that you provided, the training data, are used as a template. And if your user is talking with the assistant and the conversation that they are having is one that you provided in the training data, you will just continue to follow that same template, right? So if you already know what to do, just keep doing that. We also have rule-based policies. So here's an example where when something is done by the user, you always take the same action. So these don't have to be learned. They are just there from the beginning. So a really good example here is like if your person you're talking to says hi, you should say hi back, right? Or this second example here, greet by name. If you know that your user has provided a name and you have that information, when you say hi, when they say hi to you, you say hi username, or that's the actual username back using that template language generation. Or if someone has a question from your frequently asked questions list, and they ask that question, answer the question from your frequently asked questions list, and then just continue on. So yes, rule-based policies are certainly in terms of dialogue management very powerful. They cannot handle digressions, which is something that TED is very good at, but they can, really get you a lot of the way there. And I think to answer Varesh's question, I would add more stories. Based on your example, I think that you maybe don't have quite enough. You might also look into sort of the data augmentation that we do. So providing more short snippets of stories. Not all your stories have to be end to end. If you have 2 snippets, they'll be concatenated during training. So to answer your question, which I promised you a while ago. All right, and I know that Anonymous was concerned about time. This is my last slide. This is my main takeaway, and then I'll go back to the chat. But both rules and neural methods have a place in conversational AI. Like I mentioned, particularly in dialogue, using the data that you have to determine what to do next based on the predetermined patterns that you provided. It works. You can use it for a lot of the conversations you have, especially if as your bot is deployed, you are taking in new things that your bot is seeing that it can't handle, adding those to your training data, redeploying, retraining first, and then redeploying. Don't do them in the other order or you'll be very confused. I've done that. Yes, and we call that process conversation-driven development, like test-driven development, but it's conversations. Anyway, we've got a lot of content on that if you're more interested about what that works like in practice. So yeah, neural methods are flexible. They really open up new things. Rule-based systems are good for what they're good for, which is predictable behavior. And I think somebody brought up a script. Yeah, a lot of the behavior that people are going to come to a conversational user interface and try to do is going to be pretty predictable. And if you can handle those cases well, you're well on your way. So yeah, and I think that this last point, those of y'all who are working in commercial applications, I'm sure you've used regex this month. They're not going nowhere. All right. Kat says, do you use knowledge graphs for policies? Within the policies, not by default. You could make it such that it was so, but again, not by default. Yeah. So says the video will be posted. Stephen says Stephen, the concept of explicit slots breaks down an open-ended conversation. And I will say in Rasa, we use slots differently. These are variables that you're storing and that you have interest in and that will change the outcome of the conversation or that you will use to, let's say, pass to some code to trigger it. But yes, open-ended conversation is, like I mentioned, right? How do you know whether a conversation is good? It's question mark. I can tell how well you did a task and that's great. But yeah, Don says 80-20 rule works for me. Yes, definitely. I would say with language data, it's, Zipfian is even more, more skewed than 80-20. Clara says, do you have sentiment analysis as part of your dialogue system to determine the next action? I know that it's right at noon now. I have more time, so I'm happy to stick around for a while. But if folks have to leave, they can leave. No, not by default. I'm not gonna, okay, I have a little bit of a personal vendetta against sentiment analysis. I think that is a great teaching tool. I think situations where you actually care about sentiment are pretty small. And particularly if you're trying to detect anger, especially for English, I'm less familiar with other languages, very positive and very negative sentiment can look extremely similar. Right? Like if someone said, oh, that's effing fantastic, you would probably pick that up as having negative sentiment because they're swearing in it, even though it's very positive. Or if someone said, that's the S, right? So I'm trying to not get you demonetized by swearing. Then again, that would probably be picked up as negative sentiment, even though that's very highly positive. So, I mean, you could, I think you'd probably end up doing a lot of work for not much gain. Yeah. And then I'm trying to answer these in the turn that they came in. So I'm going to go to the chat until it gets to the one at noon, and then I'm going to answer your question, Jesse. All right. Oh, no other questions. Great. So Jesse, what's your opinion on how we get to successful open-ended chatbots with personality? That is a great question. I think I have a question that comes before that question, which is why? This is one of those applications where I can think of far more harmful uses than positive uses, right? So even if like when people start to talk about positive uses for this, it can be like, well, alleviating loneliness, which, I agree, that's a problem. It's not good to be lonely. But I can imagine even a chatbot designed for very altruistic reasons, like alleviating loneliness, could be, let's say, used as an advertising platform, which I would say would be extreme emotional manipulation, and I personally would consider unethical. Yeah, I don't know. I think it's, again, this is my opinion. I kind of think that's a waste of resources. We have, we have limited resources on every front. We have limited time, we have limited compute, like both individually and like as a species. And I just don't know that that is a great use of our time. Oh, that's my personal stance. I know that people are going to keep working on it. But if the final outcome is a fun toy that also has a lot of harm that it could do, on balance, I just don't see that as a great use of time. Sorry. I know that's a little bit of a downer, but that's my thought on it. I'm in favor of task-oriented systems when they work. They got to work. If you're wasting people's time, you don't bother. They should save people time. Yeah, I don't know. Maybe a little bit of a bummer. Yeah, and Manoush says, how do you recommend combining a rule-based system with a statistical system for classification task? The assumption is that there's not enough data to train a highly accurate statistical model. Great question. So I didn't talk a lot about how we ensemble our models. So for I think it's most relevant with the dialogue policy. We go with a confidence-based approach. So every model in the ensemble makes a guess. The model with the highest confidence wins. Rule-based confidence is always 1 or 0 because it either triggered or it didn't. So rules take precedent if they apply. Otherwise, kicking it down to whatever the output of the statistical system was, knowing that that output might not be great, and then having a floor of confidence. Thinking about confidence in this case, just a measure of how much similar data has your system seen in the past. And if it's quite a bit, then do your best. And if it's not a lot, then hitting your fallback policy, which would be something like, hey, looks like we can't help with your query. Click here to be connected to a human agent. Or here's a phone number, call this phone number. It looks like we can't help you with a chatbot. I would use a person instead. Use a person. If it's something that your system genuinely can't handle, get people out of your system ASAP, again, in the interest of saving time. Yeah. And then, scrolling up, anytime emotions get into it, you might need a link to make sense of most of it. Okay, I'm assuming this is about emotion detection rather than sentiment detection. Perhaps. Are there open source repos of labeled data? Yeah, there's some. So we actually have an NLU examples repo on the Rasa HQ GitHub. If you want to check that out, it's supposed to be like a warm start for your chatbot. And I believe currently most, if not all, of that data is in English. You may, if you sort of snoop around on GitHub, a lot of folks share their chatbots. So you might find somebody who has shared a chatbot and the data has been labeled for, your reuse of choice. So make it lucky. Yeah. Oh, Jesse has a question specific to games. What do you think of machine learning is useful to NPCs, so non-player characters? That's a great question. I know I've really been ragging on sort of open-ended conversational systems, but one system that I think that is quite good is GPT Dungeon. If y'all have used it, it's basically as if you were playing Dungeons and Dragons, but the assistant is, responding to the things that you're saying your character is doing with like what happens in the world as a result. The reason I think it's a good system, very limited use, clearly marked as a game. Lots of in-domain training data is available, well, tuning data, I guess. And it's very like clear how to interact with the system. So I'm a big fan of GPT Dungeon. I think there's potential, but also, I don't know, it seems hard. Sorry, Seth? I saw you unmuted. Acquisition of the algorithms of social life, a domain based approach from psychology reviews was the link. Oh, fabulous, thank you. Both emotion detection, agent motivation modeling, sentiment feature extraction, and more. Sounds like a good read. And I think I answered Manoush's question. And then Stephen asked next, what techniques do you specifically recommend instead of sentiment analysis on semi-supervised and unsupervised data, trying to extract relevant entities, something else? Great question. Usually when people are asking for sentiment analysis, they care about something else. So for chatbots, they may be asking like, are people saying that they're happy or sad? What they want to know is, do people are people able to do what they want to do with the system? And there are other ways of measuring that. So as of Rasa 3.0, we've introduced an experimental feature called markers. So once you have your chatbot launch, you have a tracker store, markers are a way of saying, hey, if this pattern happens in a conversation, and you just detail it in a file, like a YAML file, record it. I want to know about it. And then it, once your people have conversations, there's just like a command line script that you run. It extracts all instances of that happening in the chatbot, and lets you do a more detailed data analysis on that. So I would say focus on what it is. So if you knew about sentiment, right? If you knew like exactly how people were feeling, how would that change your behavior? What are you trying to figure out what you need to do or not? And it's rare that like just knowing how people are feeling is the thing that you care about, right? So focus on the second order thing. What are you getting sentiment to do, and trying to do that thing more directly? Like, I guess there are probably specific examples where sentiment matters, but yeah, in general, my experience has been that it's rarely actually sentiment that people care about. Anonymous says, how would you suggest a newbie starts exploring, sorry, I know I keep clicking back and forth, starts exploring conversational AI projects? Great question. We have, so we actually have a free learning resource on, I believe it's learning.rasa.com, rasa.com/learning maybe. So we have a video course that we put together. I mean, it's Rasa centric. So if you are not interested in using Rasa, there are other resources. But it's I think the course is titled Conversational AI with Rasa. It sort of like introduces you to Rasa. It's been updated to Rasa 3.0 for those of you who watched it before, and talks about a lot of the concepts. And a lot of the concepts do transfer to other frameworks as well. And I also have a series, I don't think it's on the Learning Center just yet, called NLP for Developers on the Rasa YouTube channel that talks about NLP concepts for developers. So people who, the assumption is you have a software background, but not a natural language processing background. So that might be helpful. Yeah. Is association rule mining still a useful technique? I don't know that I've heard of that. Doesn't mean it's not, just that I haven't run across it. Was that your hosting? I'm assuming that question is not for me. What do you use transformers for? Yeah. Sorry, I'm trying to like make sure that I answer questions in the order that they came in. Great question. So we use transformers for two main things. So one is handling digressions in the flow of conversation, using this transformer dialogue policy, and also as part of this dual task intent classification and entity extraction. Also, if you are using embeddings that are pre-trained using transformers, also that. We can keep going for another 10 minutes. Okay. Is there a GitHub or similar link for the Rasa API? So our API documentation is on our docs, and I believe it's a separate heading. I don't know if this is going to ruin everything or not. I'm always so hesitant to try and open links while I'm presenting. Yeah, so I would go to github.com/RasaHQ, and that'll take you to the important stuff. Okay, and then Shardul asks, are you aware of any techniques where a model can use data to generate generic and versatile rules, which can then be used, changed, or maintained by humans? Great question. I feel like that's what Snorkel was originally designed to do, that and sort of like semi-supervised data labeling, but I don't know if that's their main focus anymore. And I don't know if anything else off the top of my head, but other folks might. Generally, in a business use case, you know what the rules are because someone has put them in the PRD, which is nice. Product resource description, I think that's what PRD stands for. So I hope that answers your question. Other people might know. Thank you, Seth. Brett says, how is paraphrasing usually used in conversational agents? We were asked to look for this feature as one of the criteria, but I couldn't understand the use case clearly. Sorry, I may not have Googled enough. Also, is there any update about paraphrasing in Rasa 3.x? Paraphrasing, interesting. So based on just the word, it sounds like telling the user the intent that they just had. Sort of sounds like that. So like if the user's like, hey, I want to order pizza, and like, sounds like you want to order a pizza. Do you want to order a pizza? That sounds very frustrating as a user, but it sort of sounds like that's what you're talking about. It might also be asking about being able to handle users saying things in a lot of different ways. And if that's the case, then that's what diet's for. So if you can have one intent that people can just like say as they would say, and then they can, your system can correctly identify the intent, even if there's a lot of variation in the surface form and the way that the user says it. If that's what you mean by paraphrasing, that's how Rasa works. You provide training examples, and we use the intent classifier to figure out what we think the intent is. Oh, it's part of how Ask Jeeves worked. Query restatement. Yeah. Yeah, I guess you could do that in Rasa. I think you'd have to do some custom actions to make that work. Custom actions are code that you trigger based on the assistant turn. Oh, Chris has a great question, and I'm going to answer your question, Nicholas. How does diet apply to multi-intent use cases? Great question. We're sort of not doing multi-intent right now. It may be an experimental feature. I know that there has been work on it. Yeah, it's just like multi-labeling, right? So if you would like to extend diet for multi-intent, I think it would be pretty doable. But yeah, I would, hopefully you can see my mouse, I would add probably like another, I would explode the similarity here, and then the intent loss I would weight across the intents is how I would update that. Nicholas says, what could be an approach to handle companies that are posting on social media, like filter comments that are random comments for those that actually complain from a client? Yeah, I would say that's more sort of like a general text classification problem, and not as much a dialogue problem. I guess some social media posts, like if it becomes a long thread, you could treat it as a dialogue, but it's more like, I don't know, shouting and waiting for someone to come along and shout back at you. It's not really like, I wouldn't call it a traditional organic conversation, if that makes sense. Sorry, I keep touching my little trackpad. Yeah, I would just look into general text classification measures if you have labeled data. Don says, just flow 3 or 4 GPUs at it. Yeah, that is the downside of multi-label is I think I mentioned exploding. It's probably going to take a little bit more time. Yeah. All right. Take a big sip of coffee. Also, I don't think I put my Twitter handle in here. I am very on Twitter. It's at RCTATMAN. If anyone has additional questions that they want to ask, I may or may not answer. Certainly not going to answer next little bit. I'm going on break. But if you have additional questions, I'm on the internet professionally. Oh, thank you, Jim. Seth is running a conference, the Sentiment Analysis Symposium from 2010 to 2018. Oh, ran in the past. Oh, interesting. Yeah, I'll have to look into that. I think it was a great example of a statistical technique that did what it did, but
sentiment analysis is widely used in customer experience in particular. People who, there's a lot of snake oil there and a lot of smoke and mirrors. And I'll say that more recently, I ran conferences a couple of years ago in Emotion AI. But anyway, I think we're at a stopping point. I don't see any further questions. Let's give anyone a last chance. Okay, well, thanks very much, Rachel. This is a really engaging talk. You had lots of questions, which is the mark of a talk that is intriguing and well received and all of that kind of stuff. So really appreciate your taking the time to present today. And yeah, it was really, really good. So once again, we have a next program that is supposed to be on January 5th on quantum natural language processing. And that's not quite scheduled yet because I'm still waiting for information from the speaker. And if you would like to give a talk, anyone who's listening at an online program, you can send me a note. I am just putting my email address in the chat. That can be a short talk, even just 10 minutes, or it can be a full-length talk like the one today. So once again, thanks to everyone who has attended, and thank you, Rachel, for presenting. and I'll get the video posted within a few hours.
Thanks for having me. This is a lot of fun.